Hello, Algebra 2. So these notes are going to be kind of long, so you might want to take this video in little parts and stop and practice some of your own. So on this first page, it's sort of re-summarizing some of the stuff we've already talked about. So notice here we have a sine graph which starts at 0, starts on the sinusoidal, and continues to complete one cycle there. You have the sinusoidal axis that runs right through the middle, and then your amplitude is that distance to the high or the low from your sinusoidal. Always positive, always, always, always a positive number. We will talk about when you see a negative in front of it, it just means a reflection. The amplitude itself is a distance. The cycle is the distance it takes to complete, or the period is the distance it takes to complete one cycle. The cycle is when it starts to repeat. So if I'm starting here at 0, I go until I hit 0 again. That would be the end of my cycle, and then the cycle repeats. And the period, again, is that distance it takes to complete one cycle. So it's an actual distance that you're recording. For the parent graph, that distance is always 2 pi, which is equivalent to once around a circle. And then we saw how the domain is all real numbers. The range is between -1 and 1. So you have a maximum at 1 and a minimum at -1. All right, so we talked about graphing your amplitude. The amplitude is a vertical dilation. So you're multiplying the y values to stretch it up or down or shrink it. Now, you'll notice I took away the grid. In pre-calc, it's really important, I find, for you to know how to graph and label your axes. And so I figured I'm going to start training you now. It's very easy. So we know that in this graph, my sinusoidal axis is going to be the line where y equals 0. It's basically going to be the x-axis. The amplitude is this number in front of your trig, so my amplitude will be 4. I see nothing in front of the x, so my period will still be 2 pi. Domain and range, these are not going to change, so there, -1. Okay, so now let's do the graph. What we're going to do is we know we're going to start at 0. We're going to end at 2 pi. Half of that distance is pi. Halfway between 0 and pi is pi over 2. Halfway between pi and 2 pi is 3 pi over 2. And this is a sine graph with an amplitude of 4. So I'm going to mark this. The high is 4. The low is -4. What I sometimes like to do, remember when you were in elementary school and you learned how to graph your letters? So I like to put out a little dotted line so I keep track, since there is no graph paper below this. And then I go ahead and I graph it. So sine starts on the sinusoidal. At the next critical point, it goes up to the max, then back to 0, then down to the minimum, and then back to 0. And so you graph 5 points that oscillate between high, medium, low, medium, back and forth, and then we just connect the dots. Voila! Alrighty, let's do a cosine. Now cosine, notice this one has a 1/2 in front, so its amplitude will be 1/2. It's still going to have y equals 0 for its sinusoidal axis, in other words, the x-axis. Period will still be 2 pi, nothing changes there. This is the same. It's a little bit redundant. Okay, so now, same thing. We're going to start at 0. We're going to end at 2 pi. Half that distance is pi. You're always taking averages when you're doing the x-axis. So this will be pi over 2. This will be 3 pi over 2. Those are the critical points on the x-axis. And then my amplitude is now a half. So I'm going to go a high to 1/2 and a low to a negative 1/2. I'm going to put in my little dotted lines. That wasn't very straight, sorry, but you'll live. There we go. And I'm now going to do the graph. So to do the graph, remember cosine starts high, then hits the median, then the low, then the median, or the sinusoidal, then the high. And it looks like the handlebars when you're done. Voila. And always make it look like it's going to keep going because it doesn't stop right at those dots. There you go, the first page. Hopefully that was okay. So on that first page, we were revisiting amplitude and how that affects your parent graph. Now we're going to revisit the horizontal dilation, which affects your period. So this B value, to figure out how far you're going to go, you can always take 2 pi, which is the normal, divided by B, because remember, horizontally affects you as a reciprocal. So what we're going to do, let's look at this. So I have sine 1/3 x. Well, I haven't added or subtracted anything to my function, so the sinusoidal axis is still going to be the x-axis. My amplitude would normally sit in front of the sine. Since there's nothing there, it's 1. Now my period, because I do have this 1/3 here, my period is going to be 2 pi divided by 1/3, because that's the B value. Well, this is 2 pi divided by 1/3. I can invert and multiply, and that becomes 6 pi. So remember, 1/3 means I'm actually stretching horizontally by a factor of 3. So usually you have 2 pi, now it's going to be 6 pi. And the domain and range are the same. Oh, actually, I guess, no, that doesn't change. Okay, so if it doesn't change, I'm not going to keep filling it out. Silly. All right, so you have your sinusoidal. So now where am I going to start? I'm still going to start at 0, but where I end is 1 period later. I'm now going to end at 6 pi. So to get these other points, well, halfway between 0 and 6 pi is 3 pi. Halfway between 0 and 3 pi is 3 pi divided by 2, which is like 270. You're taking the average. To find out what's halfway between 3 pi and 6 is what's halfway between 3 and 6, 4.5. So you could say I'm just going to say 4.5. Oh, I guess I could say, what would that be? So that's 3 pi, my battery's low. Okay, so I'm just going to say 4.5 pi. I don't feel like quibbling. My brain's not working too good right now. My amplitude is 1, so I want to show my high and my low with my little dotted line. All right, and this is a sine graph, so sine starts on the sinusoidal. Then at 3 pi over 2, you're at your high, the middle. See, this way it's really nice because the only points you care about are the ones you put on the axis. And you just then oscillate between the highs and the lows, and there's your graph. All right, so let's do a cosine. So notice amplitude here is going to be 1. This is going to still be y equals 0. My period is going to be 2 pi divided by the b, which is 4. So now we're going to write that as pi over 2. So it's only going to take 90 degrees to finish one cycle. And then the domain and range are the same. So it's not very interesting. Okay, so I'm starting at 0. I'm going to end when my period ends. That's going to be at pi over 2. So I'm going to stretch it out just so it's not so kind of crazy. Halfway between 0 and 90 would be 45, which is pi over 4. Half of pi over 4 is pi over 8. So again, I'm averaging. So halfway between pi over 4, which is 45, and 90 is something. I hate doing this in radians. Okay, so this would be 2 pi over 4. That's pi over 4. Ooh. Okay, hang on one sec. I have to figure this out. Oh my gosh. Da 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 da. Sorry, I'm doing this off to the side. Da da da. 1.5. That's not very friendly. 3 over 2. So it's going to be 3 pi over 8. Took me a second there. And my amplitude is still 1, -1. Draw my little dotted line. Okay, so to draw the graph, it's a cosine. Cosine starts high. Then we start doing our oscillating middle, low, middle, high. And as your final effect, dun, da, da, there would be your handlebars for the cosine. All right, notice it has the period then of pi over 2. I know some teachers don't like my style because it doesn't really show that something got shrunk or stretched because I'm pulling it out, but I don't see the value of trying to draw in a tiny, tiny little space. So I like to do my own axes. Okay, now we're going to put those two things together, amplitude and period. So we have a sine graph. Our sinusoidal axis is still going to be 0, the x-axis. And my amplitude, which is here, is 5. My period is 2 pi divided by a half. You're going to get used to doing the invert and multiply really fast. Basically, you're always going to be multiplying those two. So it's going to take me 4 pi to finish because it's going to stretch it by twice as much. And domain and range are the same. Okay, so I start at 0. I'm going to end at 4 pi. Half that distance is 2 pi. Half that distance is pi. Ooh, this was a nice easy one. Yay. All right, and then amplitude is 5, so I'll go way up here, come way down here, do my little dotted lines, and then I mark out my 5 points. So it's sine, so it starts on the sinusoidal, then I go high, middle, low, high, no, middle, sorry, and then we just connect our dots, trying to make it look round and periodic. Okay, that's the sine. Now let's do a cosine one. So for cosine, our y equals 0, still our same sinusoidal axis. That will change, but not yet. Amplitude, the amplitude is the number in front, so that's 3. My period is 2 pi divided by 2, which is going to be just a distance of pi. So in other words, it is a horizontal shrink by a half. And then domain and range are the same. So I'll start at 0, I end at pi, half that distance is pi over 2, half that distance is pi over 4, and this is 3 pi over 4. And my amplitude was 3, so we won't go quite as high as the next door 5. And then to do the graph, it's cosine. Cosine starts high, and then we oscillate. So middle, oh, I didn't do my dotted line. Dun, 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 dun. Then we go low, then we go to 0, then we go high, and it's the cosine, so there's the handlebars. Or a big mustache or something, I don't know. Whatever you want it to be. All right, I hope you're starting to get a feel for it because there's a lot more coming. Okay, so like I said before, there's going to be the potential for a reflection of your graph. So here we have y equals -4 sine x. So we're still going to have our sinusoidal is the x-axis. My amplitude is still a positive number, but what I always do is I write down 4 and then I put a little r here to remind me this graph is going to be reflected over the x-axis because it's a vertical reflection, that negative in front. My period, because I have nothing in front of my x, is your basic 2 pi, and domain and range are the same. Okay, so we start at 0, we're going to end at 2 pi, this is going to be pi over 2. You get really good at just kind of putting in these basics. Amplitude is 4, so I'm going to go up to 4 and down to a -4. And I'm going to do my little dotted line. Okay, So it's sine. Sine starts on the sinusoidal. Normally, sine would go high, but this one is reflected, so I'm going to go low. Then I'm going to go to the middle. Then I'm going to go high. Then I come back, and that is what we call a reflected sine graph. Okay, so that's really all that is. If you see the negative in front of your amplitude, amplitude is still a positive distance. That distance from the sinusoidal to a high or a low is a distance of 4. But the reflection affects which direction you go when you start your graph. So let's look at this cosine. I notice I have a negative with no number, so that means my amplitude is a positive 1, but it's going to get reflected. And sinusoidal is still the x-axis. Period now is 2 pi divided by a third, so that's going to be 6 pi, and these are the same. So I'm going to start at 0, I'm going to end at 6 pi, this is going to be 3 pi, this is going to be 3/2 pi. What is that? That's going to 6/2. So what is this? 3, 6, 9/2? Yeah. 9/2 pi. I guess I said 4.5 on the other one. It's the same thing. With an amplitude of 1, so here's 1, here's -1. Do my little dotted line, which you don't have to do. That's just me, because I lose track of where I am sometimes. Okay, so usually cosine would start high and end high, but because we are reflected, it's going to start low, and then it does its oscillation. So then it goes medium, then high, then sinusoidal, then low, and so your graph is now sort of an upside down handlebar. That's about it, okay? All right, so we have done amplitude, we've done your horizontal dilation, which affects your period. Now you're going to get into translations, which remember does not change the shape, it just picks the graph up and moves it. This is going to change your sinusoidal axis. So it has here a K, which I've never seen it written as K before. Usually we use a capital C. That really bugs me. Okay, whatever, it's fine. So what happens here is I've got y equals 5 plus sine x. So the first thing I'm going to do, there is a way to kind of cheat with this, but I'm not going to do it because that would just confuse you probably. So I'm going to come up here and I'm going to choose a place to call 5. This is my new x-axis. This is my new sinusoidal axis. So it's going to be the line y equals 5. My amplitude is still 1. So you add and subtract to your sinusoidal. So I'm going to go up to 6 and down to 4. So I'm going to, and my whole graph is going to fall. I know it doesn't, as long as you label it, it doesn't really matter how it is. And then I don't have any change to my period. So it's still going to be 2 pi. And domain, my domain is still going to be all reals, but now my range, you can see that my range is going to go between 4 and 6. Yay, finally, something new to write, okay? Because everything's going to fall between 4 and 6. So now when we go to graph it or to label the x-axis, make sure you label the x-axis, not that sinusoidal that's up in the sky. So we're starting at 0, we're going to end at 2 pi because that's our period. Half of that is pi, half of this is pi over 2. What is this? 3 pi over 2. All right. So this is a sine graph. Sine starts on the sinusoidal, which is right here. And then it goes high, sinusoidal, low, sinusoidal. So it's basically the same graph. It just got translated up 5 units. Okay? And then we have cosine. So now my new sinusoidal right here is going to be y equals -4. My amplitude is still 1. My period is still 2 pi because there's nothing right there. There's just a 1 in front. Domain, well, let's label my x-axis now. So my new sinusoidal's here at -4. since my amplitude is 1, I'm going to come up to -3 and down to a -5. So you always add and subtract the amplitude to whatever sinusoidal is. So I can see my domain is still all real. I don't know what that, stop doing that. I lost my real. And you can see that this is going to now fall between -3 and -5. And so let's put our graph in there. What color do we want? So this is a cosine. Cosine starts high. Oh, I haven't done my x-axis. Sorry, I told you I'm really tired. There's 0. Here's 2 pi. Here's pi. Here's pi over 2. And here is 3 pi over 2. So cosine starts high, then it goes to the sinusoidal, then it goes low, then it goes sinusoidal, then it goes high, and voila! That's what it looks like when you actually translate it, which gives you a new sinusoidal. All right, kiddies, let's put it all together. So we've only got 3. There is going to be one more transformation that we will look at next week. But so now this one has all 3. So your sinusoidal is now y equals a -1. My amplitude is 2. And my period is going to be 2 pi divided by 2, which is a distance of pi. So I do the domain and the range after I've labeled everything. All right, so my amplitude, let me see, my sinusoidal is at -1. So here's -1. I'm going to put this down here. And I'm going to add and subtract 2 to that. So if I add 2, that puts me up at 1. That's where my high is going to be. And my low, if I subtract 2, it puts me at -3. So I can see, domain is always all real, that I'm going to be from 1, whoops, sorry, I should put that the other way, from -3 up to a +1 is going to be my new range. This is a sine graph, so we're going to put 0 here. We have a period of just pi. Half that distance is pi over 2. This will be pi over 4. This will be 3 pi over 4. And then we put in our dots. So sine starts on the sinusoidal. My new sinusoidal's here. Then it goes high. Then it goes here. Whoops, hey. Whoops, it's telling me my battery's low. It can wait 2 more seconds. All right, so we then still oscillate. That's why it's kind of nice to have everything labeled, because once you label everything, then it's just connecting dots. It actually goes pretty nicely. Ooh, this one has a little twist to it. So the sinusoidal is going to be y equals 2. I'm going to put a 2 right here. And my amplitude is going to be 3, but this one's going to be reflected because you have a negative in front of that 3. My period is 2 pi divided by 1/2, so that's going to represent 4 pi, a distance of 4 pi. Okay, so let's label our y-axis. My sinusoidal's 2 with an amplitude of 3, so I'm going to go up to 5. And down to a -1. And then labeling my x-axis, I'm going to start at 0. I'm going a distance of 4 pi. Half of that is 2 pi. Half of this is pi and 3 pi. Okay, so now it's cosine, but it's reflected. So I'm going to start low, then go sinusoidal, then go high, then go sinusoidal, then go low, and voila. All right, so, I guess domain, always all real, it's kind of boring, and then range is going to go from -1 to 5. Ça va? All right, try these last 2, turn off the video, try these last 2, then come back and see if you got it right. All right, but I'm going to continue. All right, so this one's going to have a sinusoidal at 3. Amplitude is 4, but it gets reflected because of this negative here. period is 2 pi divided by a third, which puts me at 6 pi. Domain's always real. Okay, so sinusoidal is going to be at 3. I'll put a 3 right here. And I'm going to add 4, so that puts me at 7. Subtract 4 puts me at -1. Okie dokie. Here's 0. Here is 6 pi. Half of that is 3 pi. Half of that is 3/2 pi. And then this was, I believe, 9 pi over 2, which is the same as 4.5 pi. All right, so it's a sine graph, but sine graph starts on the sinusoidal, but instead of going high, it's going to go low because of the reflection. Then sinusoidal, then the high, and then the sinusoidal. And we connect the dots. All righty, last one. Okay, sinusoidal, y equals 5. I get punchy when I'm tired. Amplitude is 2, period. Whoa, 2/3. So that's going to be 6 pi divided by 2. That's 3 pi. All right, domain is still all real. And let's graph this puppy. So we're going to be here at 5 for the sinusoidal. We're going to go up 2 to 7, down 2 to 3. So you're adding and subtracting these two always to get the high and the low. We're going from 0 to 3 pi. Half that distance is 3 pi over 2. Half that distance is 3 pi over 4. And then halfway between 3 pi over 2 and 3 pi, so that's 6 pi over 2, and that would be 9. Oh my gosh. Okay, 9 pi over 4. I think I did this before, didn't I? Yeah. All right. So we are dealing with what kind of a graph here? It's a cosine. There's no reflection, so cosine starts high, then goes sinusoidal. Oh, I didn't put in my dotted lines. I feel so naked. And then we go here, then we go here, and we connect the dots, and voila, we are done. And if you finish this, then you're awesome, because that was long. Range here between 3 and 7. All right, off to get vaccinated. Bye.